Hello everyone. Today we will take the new topic, that is degree of reaction. Degree of reaction is defined as ratio of change of pressure energy inside the runner to the change of total energy inside the runner. This we can also write it as pressure head to the total head. Now we know very well that in a reaction turbine, the energy, total energy which is going to enter in the turbine, that energy is partially converted into a pressure energy and partially converted into a kinetic energy. The part which is converted into a pressure energy, for that purpose the degree of reaction is used over here, which denotes that how much pressure energy is converted into the work out of the total energy which is converted into a work. Now the total head which is converted into a work, it is equal to 1 by G VW1 U1 plus or minus VW2 U2. For simplicity we will take only the positive value, so it is equal to 1 by G VW1 U1 plus VW2 U2. This is the total energy. Let's say equation number 1. Now from velocity triangle, VW1 is equal to, that means this AC is equal to AB plus BC, that means U1 plus BC, which we can again write it as U1 plus this BC is equal to under root of VR1 square minus VF1 square from this right angle triangle. Let's take this U1 on the other side, so the equation will become U1 VW1 minus U1 equal to under root of VR1 square minus, again for VF1 let's take this right angle triangle ADC, and from this VF1 will be equal to VF1 square will be equal to V1 square minus VW1 square, which we can again write as under root of VR1 square minus V1 square plus VW1 square. Now let's take the square on both sides. Square on both sides. So it will be equal to VW1 minus U1 bracket square equal to, now this under root will get cancelled, and VR1 square minus V1 square plus VW1 square. Let's take the square of this, VW1 square minus U1 square plus U1 square minus twice of U1 VW1. This will be equal to VR1 square minus V1 square plus VW1 square. This VW1 and VW1 will get cancelled, and if we rearrange the equation for VW1 U1, that means for this value, then we will get VW1 U1 equal to U1 square minus VR1 square plus V1 square by 2. So this is the value for VW1 U1. Let's search for again VW2 U2. For that, let's observe outlet velocity triangle. So from that we can write VW2 is equal to EG minus EF. EG minus U2. Now for EG, that means this one, we can write it as under root of VR2 square minus VF2 square minus U2. Again take this U2 on the other side, VW2 plus U2. This will be equal to under root of VR2 square minus VF2 square, which we can again for VF2, if we replace by using this triangle HGF, we can write it as VR2 square minus V2 square minus VW2 square. Let's take the square on both sides. VW2 plus U2 bracket square, under root sign will get cancelled and it will become VR2 square minus V2 square minus plus, so VW2 square. Let's expand this left hand side and we will get VW2 square plus U2 square plus twice of VW2 U2, and this will be equal to VR2 square minus V2 square plus VW2 square. Again VW2 will get cancelled, and let's rearrange for VW2 U2, that means this value. So VW2 U2, it will be equal to minus U2 square plus VR2 square minus V2 square. So this is equation number 3. Now let's put these two equations in total energy head. Now let's put both this equation in total head, energy head. So HT will be equal to 1 by G, and again let's take this 2 out of the bracket and we will get U1 square minus U2 square, this one term, then plus VR2 square minus VR1 square, second term, and third one V1 square minus V2 square. So these are the 3 terms which we will observe in a total energy. Now from this one, this term, it denotes the kinetic energy, change in kinetic energy inside the runner. We know very well that in a reaction turbine, part of the total energy is the kinetic energy and remaining is the pressure energy. So these both terms shows the change in a pressure energy. This is the change in pressure energy due to centrifugal action. this term denotes change in the static pressure energy, change in static pressure energy as per Bernoulli equation. Now, as per the definition of reaction turbine, degree of reaction, R is equal to HP upon HT. That means change in the pressure energy to the change in total energy. So change in pressure energy is this both terms. So we can write it as U1 square minus U2 square 1 by 2G plus VR2 square minus VR1 square divide by 1 by 2G U1 square minus U2 square plus VR2 square minus VR1 square plus V1 square minus V2 square. Now let's simplify this equation once again. So here we can see this from here. HP is equal to 1 by 2G U1 square minus U2 square plus VR2 square minus VR1 square. If we see both this equation from here, we can see we are only subtracting this, we are only taking this much value. So we can write this HP is equal to HT minus V1 square minus V2 square by 2G. If we put this value in this equation, then we can write the degree of reaction is equal to HT minus V1 square minus V2 square by 2G upon HT. So if we separate this both the terms, then we will get 1 minus V1 square minus V2 square upon 2G HT. So this is the degree of reaction for any turbine. Now let's see the degree of reaction for Pelton turbine. This is the general equation for degree of reaction for all types of turbine. Now for Pelton turbine, we know very well that U1 is equal to U2 and VR1 equal to VR2. So if we put both these values over here, we will get R is equal to U1 minus U2, this will get 0, as well as VR2 minus VR1, this will get 0, and we will get 0 divided by, again this term is 0, this term is 0, so we will get 0 plus 0 plus V1 square minus V2 square, and the whole degree of reaction will be 0. This means that in a Pelton turbine, there is no pressure energy responsible to get the work done. For Pelton turbine, no pressure energy is responsible to get the work done. Not even a part of it is responsible to get the work done. Second one, for actual reaction turbine, we consider that beta is 90 degree, so VW2 will be equal to 0, and if it is like this, then our velocity triangle at the outlet will be as beta equal to 90 degree and VW2 is equal to 0, so the total energy will be equal to 1 by G VW1 U1. Now we can write this VW1 is equal to VF1 cot of alpha. Also we can write U1 is equal to VW1 minus VF1 cot of theta. VW1 minus BC, and what is BC? VF1 cot of theta. So if we put the value of VW1 over here, we will get VF1 cot of alpha minus VF1 cot of theta. Let's take VF1 out of the bracket and we will get VF1 cot of alpha minus cot of theta. If we put value of VW1 and U1 over here, we will get HT is equal to VF1 upon G cot of alpha in bracket cot of alpha minus cot of theta, VF1 square. Okay, this VF1 and this VF1. So this is how we will get the denominator of the reaction, degree of reaction. Now let's find out V1 and V2. V1 square minus V2 square, this will be equal to V1 square minus, we know very well that here, from here you can see V2 is equal to VF2, so we can write VF2 square. V1 we can write in terms of VF1 cosec alpha, so VF1 cosec alpha square minus VF2 square. Now for reaction turbine, we also consider that VF1 equal to VF2, so we can write VF1 cosec alpha minus VF1 square. So let's take VF1 out of the bracket and we will get cosec alpha minus 1, cosec square alpha minus 1. This is also square. Again, cosec square alpha minus 1, it is equal to cot square alpha. So we can write VF1 square cot square alpha. Now let's put this equation number, let's say 1, and this equation number 2, put this equation in the degree of reaction. So we will get R is equal to 1 minus VF1 square cot square alpha divided by VF1 square by G cot alpha minus cot theta. So one of the cot alpha will get cancelled, as well as vf1 square will get cancelled, and yes, one more term is there, that is multiply by 2g, this one. So we will get the equation as 1 minus cot of alpha divided by twice cot of alpha minus cot of theta. So this is the equation for actual reaction turbine. So if we know angles of the reaction turbine, we can find the degree of reaction. Let's again revise that what is degree of reaction. So degree of reaction, basically it is a percentage of how much pressure energy out of the total energy is responsible to convert into the work done, and it is defined as change in pressure energy inside runner to the change in total energy inside runner. Which we can again write it as in terms of head, that is pressure head upon total head inside the runner.